Hey guys, welcome back. Today I'm gonna work on a new accelerometer sensor, that is MXC6232xM. Now we have been working on a different digital accelerometer sensors. Let's add a new one to that list. So to gain more knowledge about this sensor, we have to visit the website, that is controleverything.com, and here we have to search for this sensor, that is MXC6232xM. Now we can say that it's a low power plus minus 2G dual axis accelerometer, and these are XY axis 8-bit acceleration AD output plus minus 2G. Some of its features, as you can see on my display. Now you can also purchase the sensor from here. You can add to cart here. I will be interfacing the accelerometer MXC6232xM with the BeagleBone Black, and the language platform will be the C code. And to get their hands on the code, let's go to Resource tab, and here we have the C code sample onto the screen, and you can download the code sample from this very site, right from here. Also, you can get the code from github.com, and the concerned repository there will be Control Everything Community. Now let's have a look over the hardware connections we need to put up together. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what do we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. This here is our sensor, that will be MXC6232xM, and these are connecting cable. Now make the connection among the cable and the sensor, and make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the ground of I2C Shield. Now as we are done with the connections part, let's move to the interfacing part, and let's see what the code is about. Now let's have a look over the interfacing part, and we need to log into github.com, and after that we need to search for the repository, that will be Control Everything Community. And here we go with the sensor, as you notice, MXC6232xM, and this here is the C code. Let's have a look over the instructions part. As you notice, we need to set up our BeagleBone Black, and beaglebone.org will help us to do so. The steps are clearly provided on this very link. As you go down further, you will notice everything here. Please do it carefully. After that, we need to download the code onto the BeagleBone Black, and we need to compile the C code. This is the command for that, and this will run the C code. Now get back to the C code. As you notice, it's a .c extension file, and the first thing you notice in the code that we have included some of the header files here. In the void main function, we want to check whether the I2C bus is open or not, and whether the address of the sensor that we have connected is 0x10 or not. Then we are going to set up the accelerometer to begin reading, as you notice, from 0x00, and here we are going to read data from the register 0x00. The command is here. After that, we are going to convert the data, and as you notice, we have the data conversion for x-axis and y-axis, and we have applied some instructions for the conversion part, because we have seen that in the instructions of the data sheet for MXC6232xM clearly. After that, at the very end of our code, we need to show the output data onto the screen. As you notice, we have the raw values for acceleration in x and y axis. So this is how the code looks like. Now let's see how it works. Now let's have a look over the working session, and in this part we need to copy the entire code, as you can see on my screen, and we need to go to terminal connected for the BeagleBone Black, and here we have to create a new file, as you can see onto my screen, and here we go. It's a .c extension file, and let's see what we got here, and we have to paste the entire code, and then we have to save it. Now for the compilation step, as you can see on my screen, this is the command, and full command is here, 6232, and let's see what we got here in the compilation. and great, it's done. Now for the building of the code, this is the command as you can see on my screen, and we run it, and we have the acceleration in both the two axes, x and y, which are the perpendicular axis. When I run the command, the axis positions the almost the same value because there is no motion and no interference. But when I try to move the sensor and run the command, we can see the changes reflected onto the screen for the acceleration in x and y axis. The perpendicular axes are there, and when I move the sensor in different directions, the change in the values for the acceleration in both x, y axis reflected. Now this is how the sensor works. Now let's have a look over some of the features, applications and benefits. The MXC6232xM is a low-cost, dual-axis accelerometer fabricated on a standard submicron CMOS process. It is a complete sensing system with an on-chip mixed signal processing and integrated I2C bus, allowing the device to be connected directly to a microprocessor, eliminating the need for A to D converters or timing resources. The sensor measures an acceleration with a full-scale range of plus minus 2G and a sensing of 512 counts per G at the rate 3.2 volt at 25 degrees Celsius. It can measure both dynamic acceleration and static acceleration. This allows to be used in a lot of applications like information appliances, for example, cell phones, PDAs, computer peripherals, consumer appliances like LCD projectors, pedometers, blood pressure monitors, gaming appliances like joystick, RF interface, alongside GPS appliances like electronic compass tilt correction, and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.